Hi, welcome to the session 4 on the core Java tutorial series. We started off with the JVM architecture in our very first session. So we learned about the virtual machine, the various types of virtual machines. We have the application-based virtual machines, we have the hardware-based virtual machines. After that, we had a look on the basic architecture diagram of JVM. Then we studied about the class loader subsystem and all the steps which are involved in loading of a class in the JVM's memory area. Okay, so the three basic steps which are involved in loading of a class in JVM is loading, linking, and initialization. And we covered all these three steps in detail in our previous sessions. After that, we started off with the class loaders. That is the various types of class loaders that are available to the JVM. We have the bootstrap class loader, we have the application class loader, and we have the extension class loader. The responsibility of the bootstrap class loader is to load classes from the bootstrap class path. That is this one. This is the bootstrap class path. The responsibility of the extension class loader is to load classes from the extension class path. That is this one. And the responsibility of the application class loader is to load classes from the application class path or the environment variable class path. The Bootstrap class loader is written in C and C++ language, whereas the extension and the application class loaders are written in Java language. So today, basically, the agenda for today will be how Java class loaders work. That is, how using all these three different types of class loaders, JVM loads a class into the memory area of JVM. Okay, or sorry, the class, how this using all these three class loaders, our class loader subsystem loads the classes into the memory area of JVM. So we will be learning about the delegation hierarchy algorithm or the algorithm which is involved in loading of a class using all these three different types of class loaders into the JVM's memory area. So say for instance, we have a program and inside that program, we have this line of code. So basically this line of code will request JVM to load a class named student. So as a parameter, we have sent the fully qualified name of student class. So student class is the example class for our use case currently. So class.forName actually loads the class which is sent to it as a parameter into the JVM's memory area. So on encountering this line, JVM will request the class loader subsystem to load the class student into the JVM's memory area. The class loader subsystem, what it does is it will check in the memory area whether the student.class file is already available or not. If it is already available, then well and throughout the program, that .class file instance will be used throughout the program, lifecycle of the program. And if it is not present, then the class loader subsystem will delegate its request to the application class loader. The application class loader, on receiving the delegated request by the class loader subsystem, will again, without taking any action, delegate the request to the extension class loader. Same, the extension class loader will delegate the request to the bootstrap class loader without taking any action on the delegated request that is sent by the application class loader to the extension class loader. Now the bootstrap class loader has the final delegated request. What the bootstrap class loader does is it checks in the bootstrap class path whether that class is present or not. If it is present, then it will load it into the memory area of JVM. If it is not present, it will again delegate it to the lower in hierarchy extension class loader. The extension class loader, on receiving the delegated request by the bootstrap class loader, will check for the class in the extension class path. If it is present in the extension class path, well and good, it will load the class file into the JVM's memory area. If it is not present, then it will again delegate it to the application class loader. Application class loader, on receiving the delegated request, will search for the class in the application class path. If it is present in the application class path or the environment variable class path, it will load it into the JVM's memory area. And if it is not present here also, then this class not found exception will be thrown by the JVM. Okay. So this is basically it about the delegation hierarchy algorithm for loading classes by the class loader into the JVM's memory area. Okay. So the topic that we're going to discuss next is the need for or how to implement customized class loaders. Okay. So the default class loading mechanism might not suffice us in some of our requirements. Then in such cases, the customized class loader comes into play. Therefore, we can say that JVM provides us with the privilege of designing or creating our own class loading mechanism. Okay. So before starting off with the customized class loading mechanism, we'll see an example of how the default class loading mechanism is used for loading classes inside a program. Say, for instance, this code snippet is for the program which uses the default class loading mechanism, and this one is for the customized class loading mechanism algorithm. So we say, for instance, we have lines of code like this: student s1 equals to new student, and then some lines of code, and after that again we encounter this student s2 equals to new student. What the default class loading mechanism will do is, on encountering the student s1 for the first time, it will check it will actually request the class loader subsystem to load the student class into the memory area of JVM and make it available for the program. So if it is there inside the memory area of JVM, then it will be used throughout the life cycle of the program. And if it is not available, then it will be loaded for the very first time. So after now this first line has been executed, and the student.class file, say for instance, was initially not present in the memory area and is now present after loading by the class loader subsystem. We encounter this second object instantiation for the student class. So on encountering this second line, what JVM class loader will do is, it will again check whether it is available in the memory area of JVM or not. If it is present, well and good, it will use that already existing .class file information. But here the point is, this class file might have some changes inside it, like the class file might have been updated meanwhile before coming to the student s2, this line, ninth number line. So the new or the updated version of the student class is not available in this program using the default class loading mechanism. So if our requirement says that we need the updated version of the class every time we instantiate an object of the student class, then we should go for the customized class loading mechanism. So what will happen in the customized class loading mechanism, or what is the idea based on which we will be designing our customized class loader is, for the first time, the default class loading mechanism will load the class into the JVM's memory area. On encountering these like loading of classes for the second time, lines which are involved with loading of class for the second time, student class for the second time, there will be a check that whether the uh, .class file of student class has been updated or not. If it is updated, then it will again be loaded into the JVM's memory area. And that newly updated version of the student.class file will be used throughout the lifecycle of this program. That is, every time we instantiate a student object, we will be using the new or the updated version of the student.class file. And if it is not updated while on reaching the second line, say the student s2 equals to new student, then it will be using the old .class file which is available in the memory area. Okay. So how to implement this? So for implementing this, JVM has provided us with the class loader class. Okay. So we have java.lang.classLoader class. We need to extend this class loader class in our customized class loader with our customized class loader class. So we have a load class method which needs to be overridden in our extended class. Okay. So, and we need to write our logic for loading the class inside this load class method. So for our use case, we will be checking whether the updated version of the class file is available or not. If the updated version is available, then it will be loaded into the memory area of JVM. And if it is not available, then the existing dot class file information will be used to instantiate all other objects of that class. So this is basically what will be written inside this load class method. So this is basically a rough implementation. I have not like written all the exact code for the implementing this use case. This is for our understanding purpose basically. Now, how to use this class loader? So I have designed a class test, and inside this class test, I have a main method. For the first time, I will allow our default class loading mechanism to load the student.class file into the memory area of Gmail. So on encountering the student s1 equals to new student, the default class loading mechanism will check whether the student.class file is available in the JVM's memory area or not. If it is available in the memory area of JVM, then it will be using it inside. Then that dot student dot class file will be used to instantiate this student s1 object. And if it is not present, then it will be loaded for the very first time in the memory area of JVM. Now we have defined an object of the class custom class loader class. And so from now onwards, we'll be using this custom class loader classes object to create objects of student class or to load the student class. Now, on encountering this line, what will happen? It will be checking whether the updated version of this student.class file is present or not. If it is present, then it will be using that. Like if the updated version is not present, then it will be loading it into the JVM's memory area. And if it is already present, that is if the class file has not been updated meanwhile, then it will be using the older version of the student.class file for loading the class. And now, say for instance that student.class file has been updated while encountering this load class for the third time. So what it will do is the customized class loading mechanism will do is it will load the updated student.class file into the memory area of JVM and make it available for usage in this program throughout the life cycle of this program. So basically what will happen in this program is we have the updated version of the student.class file every time we want to instantiate our student object. Okay. So this is how we implement customized class loader in our program. So we may be now thinking about like where is this thing used actually. So we have an use case for this. So while developing web servers and application servers, in these areas the performance is very important, and to improve the performance of class loading, we may make use of customized class loader. So this is all about customized class loader and the delegation hierarchy algorithm, or how the how the class loaders function. So this is all about the session for today. Let me know in the comment section if you have any doubt. In our next session, we will be starting off with the memory area of the JVM. That is the most interesting topic, I guess, for this like JVM architecture session. Okay. So thank you. Thank you for your time. Let's end this session here.